Hello students, now in this video we will be studying about Runja-Kutta method of second order. This Runja-Kutta method of second order is also known as Euler's modified method. Euler's method is the Runja-Kutta's method of first order and Euler's modified method is the Runja-Kutta method of second order. Now we'll see how this Runja-Kutta method works. Now we are given any differential equation of first order. Okay, dy by dx is equals to f of x comma y, and y of x not equal to y not be the initial value conditions which are being given. Okay, now the computational formulas are, suppose k1 is defined as h of f of x naught comma y naught. This finding is easy. Why? Because x naught and y naught will be given to you all. H is the distance between two points x0 and x1, x1 and x2, etc. And that h value, also called as in step value, that is also given to you. So once that has been done, you will be able to find k1. Once k1 has been found, you have to go for k2. K2 is given by h, which is also known f of x naught plus h comma y naught plus k1. So this k1 value which you get here, first you have to substitute here. Okay, y naught plus k1. And f of x naught plus h comma y naught plus k1, f value you know, which is given by this. Okay, so in this way you will calculate k2. Now once k1 and k2 has been calculated, my next step is to find k. And k is the average of these two. Then next is about yn plus 1, and it is given by yn plus k. So and k is what? The average of these k1s and k2s. So for example, if I want now x naught is there, y naught is there. If I want to find y1, it will be what? Y naught plus k. And this k value is what? K1 plus k2 upon 2. And I have the formulas for calculating this k1. I have the formula for calculating this k2. Okay, so my first step after any problem is given will be finding what is f of x comma y, knowing x naught and y naught values, knowing the h value, and once h value has been known, find k1, then find k2, then find k, and then go and find yn plus 1. Okay, so let's look at an example. Use Runja-Kutta method of second order to find y when x equal to 1.2. Okay, so you have to find y of 1.2 in steps of 0.1. Now in steps of 0.1 says that h is equals to 0.1. Given that dy by dx is equals to x square plus y square, and y of 1 is equals to 1.5. Now from this we know that f of x comma y is x square plus y square. And with these initial conditions, we know this is y of x naught comma y naught. So I have my x naught to be 1 and I have my y naught to be 1.5. Now I need to find the value of y when it is x equal to 1.2. When will be this x will be 1.2? In steps of 0.1. See, x naught is 1, x1 will be x naught plus h. Okay, x naught is 1 plus h value is my 0.1. So x1 will be 1.1. Okay, then next will be x2. x2 will be x1 plus h. That is what? x1 is what? 1.1 plus 0.1. That is 1.2. This becomes my x2. So basically, I will have to find my y value at x2. So basically, I want to find y2 at x2. Okay. So this is my question. And to find y2, we have this formula, y of n plus 1 equal to yn plus k. So basically I want here y2. Y2, that means what? Y1 plus 1. N will be 1. That means it will be y1 plus k. That means I need to first find y1. And I already have y0. Now y1, how you will find? Y1 will be given by y0 plus k. Okay. So now to find, my first task will be to find k. Y0 I already know. That is 1.5. Now my first task is to find k. Okay. So we'll start. Y1 will be y0 plus k. And my k is what? K1 plus k2 upon 2. And my k1 is what? K1 is h into f of x naught comma y naught. I know x naught is 1, y naught is 1.5, h is 0.1. So I have k1 equal to 0.1 into f of 1 comma 1.5. And what is f of x comma y here? It is x square plus y square. Okay. So it will be what? 0.1 into 1 square plus 1.5 the whole square. Okay. And when you solve this, the answer comes to 0.325. This becomes my k1. Next step is finding k2. K2 is given by what? H into f of x naught plus h comma y naught plus k1. Now h we know already, it is 0.1. F of x naught we know, x naught is 1 plus h is 0.1 comma y naught we know already, that is 1.5 plus k1 we have just now calculated, that is 0.325. So this one will be 0.1 into, now f of this comma f of x comma y is what? X square plus y square. So this is what? X term will be 1.1. So 1.1 square plus this part will be 1.825 the whole square. Now when you compute this, it will be come to 0.4541. So I have now found my k1 value, I have found my k2 value. Okay, for this first iteration. Now my k value will be given by the average of these two. Okay, so next step will be finding the k value. K value is what? K1 plus k2 upon 2. So k value here, k1 is 0.325 plus k2 is 0.4541 divided by 2. And this, if you compute, it gives 0.3896. So this becomes my k value. Now once k value has been known, I will go and find y1. Y1 is given by y0 plus this k value. Y0 was my 1.5, which was given, k I calculated to be 0.3896. So my y1 comes to 1.8896. Okay, so this becomes my y1 value. So here my first iteration ends. Y1 is what? Y at x1. Okay, and what is was my x1? Y of x1 was my 1.1. C of x1 was I calculated to be 1.1. Okay, so y of 1.1 or y1 is 1.8896. Now, my next step is calculating y2. Okay, that is my final task, calculating y2. That is what? Calculating y at x2. And what is my x2? Y 1.2. The question is finding y value at 1.2. Okay, so now to find y2, I will have to repeat all the steps again. Okay, so now again I will start calculating k1, k2s, and so on. My k1 will be there, my k2 will be there, my k will be there, and then again y2 giving y1 plus this k value. Okay, so I'll start calculating with k1. K1, now in this case it will be h into f of, now in this case it will be x1 comma y1. Now I'm in iteration 2. Okay, in the iteration 1, k1 was given by h of f of x naught comma y naught. In iteration 2, it will be k1 will be equal to h of f of x1 comma y1. Okay, so now h value I know 0.1, f of x1 value I know it is 1.1, y1 value I just now calculated, that is 1.8896. 1.8896. Okay, so it will be what? 0.1 into 1.1 the whole square plus 1.8896 the whole square. And if you calculate this, it comes to 0.47802. This becomes my k1 value. Okay, now next step, once k1 has been done, calculate k2. K2 will be given by what? H of f of. Now earlier case, in iteration 1 it was x naught plus h and y naught plus k1. Now in this second iteration it will be x1 plus h and y1 plus k1. Okay, f of x1 plus h, y1 plus k1, k1. Okay, h will be 0.1 as it is. F of x1 we calculated to be 1.1, h value is 0.1, comma y1 we calculated to be 1.8896 plus k1 value, this k1 value 0.47802, that is 0.1 into f of 1.2 comma 1 point, or I can say this goes to 2.3 and so something. Okay, this will be some value. When you calculate it further, you get it to be 0.7045. This becomes your k2 value for your iteration 2. So now you have got k1 and k2s for your iterations. You have to check for k value. K value for your iteration 2 will be k1 plus k2 upon 2. K1 is 0.47802 plus k2 is 0.7045 divided by 2. Once you calculate this, you will get k value to be equal to 0.5912. Okay, now once k value has been done, my next step is finding y2. Y2 is given by y1 plus k. Y1 we had calculated earlier. Okay, in from iteration 1, I have got y1 to be 1.8896. 1.8896 plus k value which I just now calculated 0.5912, and this comes to 2.4808. That is my y2 value is 2.4808, and this was the required value. Y2 is y at x2, that is y at x2 was my 1.2, and this is that particular value 2.4808. Okay, so this is how we calculate. If it was asked x at 1.3, suppose in the question, if instead of 1.2, if the question was find the value of y at x equal to 1.3, you would have gone one step further. That is, you would have gone for the third iteration. Okay, in the third iteration, the things would have been changed something like this. Iteration 3, you would have required y3 is equals to y2 plus k, and k was given by k1 plus k2 upon 2. Okay, and in this case, in this third iteration, k1 would have changed to f of, sorry, h into f of x2 comma y2. Okay, and k2 would have been changed to h into f of x2 plus h comma y2 plus k1. Okay, then k to be given by average of k1 and k2, and y3 to be given by y2 plus k, and this way it would have been extended further. Okay, so now since only y at 1.2 has been asked, this is our final answer, y2 to 2.4808. If y of 1.1 would have asked, we would have stopped here and we would have just found y1, that is y at 1.1, that is 1.8896, and we would have stopped. Okay, so this is about the second order Runche-Kutta method, also known as Euler's modified method.